Hello. In this video, we are going to look at the transformation of variables in thermodynamic functions. We recall that by definition, the enthalpy H is the internal energy U plus the product of the pressure and the volume. The Helmholtz free energy A is the internal energy U, and then we have it subtracted this product, the entropy S and the temperature T. In the third case, for the Gibbs free energy, we have the enthalpy H, and we subtract from that this product of the entropy and the temperature. We notice a common pattern here, and this suggests the idea that we can think of a thermodynamic function G as being formed from another function f to which we add the product of a variable y and the variable z. So ultimately we can think of this type of a transformation as a way of going from a function f of x and y to a function g, which is a function of x and z. We shall now prove that if we have functions f and g of this type, and we know that the exact differential, total differential of df can be written a times dx minus z dy. So this is if to prove then that the differential g will be a times dx plus y dz. Our first step is simply to start with our given information, and we see that g is equal to f plus yz, so it's in the form of three of our important thermodynamic functions. So then we want to compute is the total differential of g. So we know that dg, just by definition and of the function g, is equal to df. And then we have to use the product rule for differentials, just as we would use the product rule for the product of two functions. So we know that's going to be the first times the differential of the second, so we have y dz, plus the second, which is z, times the differential of the first. So that gives us dy. So we're just able to do this by using the rules of differentiation on our given function g. Next, we can substitute our expression for df into our expression for dg. So we have dg is equal, and now we'll even put our expression for df in purple because that's the color we've written it up there. So that is our a times dx minus z dy. And then continuing, we have plus y dz plus z dy, or z dy if you say. Now we notice that minus z dy and plus z dy will cancel each other, and we're left that the dg is equal to a dx plus y dz. And we notice this is exactly what we had wanted to prove, and the proof is finished. Thank you very much for your attention. Have a good one.